Okay, so let's start. Okay, so I will share my screen now. Okay, so hope everyone can see my screen. Yeah.
Yes, we can.
Thank you. All right, so today we will learn the most important subtopic. Yeah, today we will learn the most important subtopic in this entire chapter. Okay, today we will learn two important things. The first thing we will learn today is that we will learn the factors. Okay, we will learn the factors that actually affecting rate of reaction. Okay, after that we will learn another concept called collision theory. So same thing, you don't need to copy anything on the notes. Okay, I will snapshot it and then make it into a PDF file and send into our WhatsApp group later. Yeah. All right. So let's start with this. Okay. So when we come to the factors, okay. So there are total 5 factors. Okay, you all need to know there are total 5 factors which actually affecting rate of reaction, which means to say, if you want to make your reaction become faster or slower, to make a reaction become faster or slower, there are 5 things you can play around. Yeah, there are 5 things that you can play around. Okay, the first factor is called temperature. Yeah, the first factor is called temperature. So by changing temperature, we can change the rate of reaction. The second factor is called concentration. Okay, so concentration also another factor that can potentially change the rate of reaction. Then we have pressure. Yeah. After that, we have something called size. By changing the size, we can change the rate of reaction as well. And lastly, we have something called catalyst. Yeah. So these are 5 factors that can potentially change the rate of reaction. Yeah. So if you want to make the reaction become faster or slower, these are the 5 things that you can play around. Yeah. These are the 5 things that we can play around. Okay. So now, first of all, we need to know how these 5 factors affecting the rate. How does these 5 factors can affect the rate? Let's start with temperature. So when temperature increases, when we use a higher temperature, our rate also increases. Okay, when temperature increases, our rate also increases. In the other word, when temperature is higher, reaction is faster. Example, let's say now we want to dissolve something. Let's say here we have 2 cups of solution. The first cup of solution is 30 degrees Celsius. The second cup of solution is 80 degrees Celsius. So both you go to put in 1 kilogram of sugar. You put 1 kilogram of sugar into both beakers. Common sense, 1 kilogram of sugar should dissolve faster at 80 degrees Celsius. Okay, so the concept is simple. When the temperature is higher, your chemical reaction will be faster. Yeah, that is concept number 1. Concept number 2 is concentration. When concentration increases, when we use a higher concentration, our chemical reaction will become faster as well. When we use a higher concentration, our rate will become higher as well. Example, now we have 2 medicine. Yeah, so this is medicine A and this is medicine B. So these 2 medicine is used to treat headache. Yeah, so let's say we have headache lah. So we have pain. So we want to take the medicine to stop the pain. Medicine A, it's low concentration. Medicine B has high concentration. So common sense, when the concentration of the medicine is higher, which means that the medicine is more powerful. Okay, the medicine is more powerful. If the medicine is more powerful, so it takes a shorter time for to relieve the pain. Yeah, it takes a shorter time to relieve the pain. Example, if you take the medicine A, which is low concentration, it is not so powerful. Maybe you have to wait 30 minutes, then only you don't feel the pain. But if you take medicine B, which has high concentration, so it is more powerful, maybe it takes 10 minutes only. so you won't feel the pain already. Yeah. So the higher the concentration, the faster the reaction. Yeah. The third one you need to know, it's called pressure. Okay, pressure only work for gas. Pressure is only for gas. Yeah. Liquid and also solid, they won't ask about pressure when you come to chemistry. Yeah. In chemistry, pressure always focus on gas only. Yeah. So now what we need to know, when pressure increases, okay, when we use a higher pressure, our chemical reaction is faster. The rate will increase. Okay, when we use a high pressure, our chemical reaction will become faster. So I give you an example. So one of the example is pressure cooker. So pressure cooker is a very special device. It's a very special cooker that allow us to cook at high pressure. Okay, so I believe most of you heard about pressure cooker before, but what's so special about pressure cooker? Pressure cooker can really shorten the time of cooking by a lot. Example, let's say initially to boil a soup, it needs 3 hours in a normal condition. But when we go to use a pressure cooker, instead of 3 hours, now we can get the soup done in 1 hour. Yeah. So pressure cooker cook using high pressure, which will speed up the whole process. Yeah. So the concept is the higher the pressure, the faster the reaction. Yeah. So higher pressure, higher rate. Okay. Next one is size. Size also another factor that can affect the rate. Okay. Size only workable for solid. Only solid. Okay, we will use a size. You never heard the liquid is small, the gas is big. No. Okay, size only work for solid and also as for solid only, yeah, nothing else. So size, you need to see two things. Big size, normally they love to use the word called granule, G-N-A-N-U-L-E, granule, or they can use the word chip, calcium chip, calcium granule, means big size. Small size, they love to use the word called powder. Okay, they can use the word called powder for small size. Yeah, so that's what we need to know. Okay, size is a bit terbalik. You see previously all increase one. Temperature higher, rate higher. Concentration higher, rate higher. Pressure higher, rate is higher. Size is terbalik. The smaller the size, the higher the rate. The smaller the size, the higher the rate. Okay, imagine this. If let's say now we have one potato, okay? So this whole potato, you cook it, okay, this is 1 kilogram of potato. You cook it directly. Compared to the 1 kilogram of potato, you cut into smaller cube. Still 1 kilo, but you cut the potato into some smaller pieces. So you should know that if I cut the potato into a smaller piece, so I need a shorter time. Yeah, I need a shorter time to cook the potato. Okay, so it proved that the smaller the size, the faster the reaction. Yeah, so that's what you need to know. Okay, smaller size, reaction become faster. Okay, the last one is called catalyst. Okay, the last one is called catalyst. Okay, guys, can you type in the chat box and let me know? Do you know what is catalyst? Can you type in the chat box and let me know? Do you know what is catalyst? Okay, so guys, type in the chat box and let me know. Do you know what is catalyst? What about the rest? Okay. Okay. All right. Okay, since majority of you don't have the concept of what is catalyst, okay, so let me share with you what is catalyst first. Okay, so let us learn something. What is catalyst? Okay, so what is catalyst? Okay, So catalyst is a special substance. Catalyst is a special substance that actually can be added. So this is a special substance that can be added into a chemical reaction. So we purposely add a substance into a chemical reaction. So why? Why we want to add catalyst to the chemical reaction? Because catalyst can help us to speed up the reaction. Okay, something that we purposely add into the reaction to speed up the reaction is called catalyst. Example. So let's say, okay, initially this is a reaction. This reaction got zinc and hydrochloric acid. Yeah, this reaction takes 10 minutes to react. So now I have zinc and hydrochloric acid. I add with a special substance called copper sulfate. The copper sulfate is a catalyst. So when you add catalyst, the reaction now speed up. So instead of 10 minutes, now it becomes 3 minutes, for example. Yeah. So catalyst is a substance that we purposely add in to speed up the reaction. So that is catalyst. Okay. Anything that we purposely add to the reaction to speed up the reaction is called catalyst. And guys, actually, you don't need to look far. Every one of us, you, me, every one of us, all the human, we have catalyst. Okay, all of us, we have catalyst in our body. Okay, in our body, there is a catalyst called enzyme. Yeah, so we have a special types of protein in our body called enzyme. Enzyme is used to speed up many process in our body. Yeah, enzyme is a catalyst, okay, in our body that can help us to speed up the reaction in human body. Yeah. So guys, did all of you is all of you have a better idea what is catalyst now? For those who don't know what is catalyst moment ago, do you know what is catalyst now? Type in the chat box and let me know, please. Okay, good, Amanda. Okay, good, Nuri. Okay, good, Jeanine. Okay, all right. So hopefully all of you know what is catalyst now. Huh? Okay, now everyone look back. So catalyst, normally we don't use the word increase or decrease one. Normally we don't say the catalyst increase or decrease. Catalyst normally is you use it or you don't use it. So when we use the catalyst, the rate become higher. Yeah, when we use the catalyst, our chemical reaction become faster. Okay, so that is what we need to know. Okay, so let's do a quick summary again before we do some exercise. Huh? Okay, there are 5 factors that can affect the rate of reaction. So, which is temperature, concentration, pressure, size, and catalyst. Okay, so we need to know how these 5 factors affecting our rate of reaction. Okay, now let's try to do some exercise together. Let's try some exercise. Hopefully this exercise gives us a better idea. So everyone, bring out your exercise booklet. Bring out your exercise booklet. Yeah, bring out the exercise booklet. If you don't have it, you can look at the soft copy here. Yeah. So bring out your exercise booklet. Okay. So we will discuss a few questions together. Yeah. So bring out your exercise booklet. Okay, if you have it, and then we will discuss a few questions together. Yeah. Okay, so first of all, turn to page 11. Yeah, first of all, turn to page 11. Let's have a look how the question works. Yeah, page 11. Okay, let's try to do it together. Okay, page 11, look at the first question. This is SPM 2003. Yeah, this is SPM 2003. Okay, we need to modify this question a bit. Okay, the equation show a reaction to produce hydrogen gas. So we want to produce hydrogen gas. That's why you can see H2, hydrogen gas is produced. Okay, which of the following is true about the equation? Okay, so this question is wrong already. So I want you to cut the entire question and change the question. What can be done to speed up the chemical reaction? So I want you to modify the question. What can be done to speed up the chemical reaction? Yeah. So we have 4 answers here. A, increase the time of reaction. Okay. So B, increase the volume of acid. C, increase the size. D, increase the temperature. Okay. A, increase the time. So time, when we increase the time, the reaction should become slower. We don't want to make it slower, we want to make it faster, right? Number 2, increase the volume. Volume is not the 5 factor. Just now look at the 5 factor we have. Volume is not there. So volume do not affect, do not kacau the rate of reaction. Yeah? Volume do not affect the rate of reaction. Yeah? So we don't go for volume. C, increase the size. Size, when we increase the size, if the size become bigger, the speed of reaction become lower. Okay, remember, if you want to speed up the reaction, you want a smaller size. Yeah, so wrong. So answer should be D, increase the temperature. The higher the temperature, the faster the reaction. Yeah, that is what we need to know. Okay, so that's the first one. Okay, another one question is turn to page 14. Okay, turn to page 14. Okay, everyone turn to page 14. Okay, page 14, look at the first question. This is SBP trial 1122. So this is a trial exam paper, a percubaan paper, yeah? Okay, so let's look at it. Okay, so the question asks, the rate of the reaction above can be increased by how? So how to speed up the reaction? So how are we going to speed up the reaction? A, grind the marble chip. Okay, I hope everyone know what it means by grind. Grind means that we make something become powder. Okay, we make something to become powder. That is called grind. So when we make something become powder, powder has a smaller size. So when we have a small size powder, your reaction should be fast. Answer A is correct. Look at the answer B, lower the temperature. When the temperature is lower, reaction become slower. Okay, C, use a larger flask. No matter you use a large or small flask, no matter you use a big container or small container, it didn't kacau the rate of reaction, yeah? It didn't affect the rate of reaction. So no. D, add water to acid. Now this is very, very interesting. This is very, very interesting. This is related to something that we learned before in chapter 6. When you add water to acid, whenever we add water to a solution, when we add water to a solution, we are doing a process called dilution. When we add water to a solution, we are doing a dilution. And what dilution doing? Dilute. Dilute means that the concentration will decrease. Yeah. So when we add water to a solution, we are doing dilution. Dilution lower down the concentration. When concentration lower, rate should be lower. Yeah. Lower concentration, reaction becomes slow. But now we want to make the reaction fast. So D is wrong. So among all, the best answer is A. Yeah. Okay, guys. The first 2 questions. So far, so good. So far, so good for the first 2 questions. All right, great, very good. Okay, so let's try a few more questions together. Okay, let's turn to page 21. Yeah, let's turn to page 21. Okay, let's turn to page 21. Okay, page 21, look at the third question. This is SPM 2010. This is SPM 2010. This is the real SPM past year question. So the following questions show the reaction between zinc powder and hydrochloric acid. So we have zinc and we have hydrochloric acid. So how the rate can increase. So when they want to increase the rate means they want to make the reaction become faster. So how to speed up the reaction? A, increase the size of zinc. So the size bigger, the reaction become slower. The one. Okay, remember, if you want to make the reaction become faster, you must use a smaller size. For example, you use powder. Okay, you must use a smaller size. B, increase the volume of water in acid. When they add water to acid, they are doing dilution. Dilution is decreasing the concentration. When concentration decrease, the rate should decrease as well. So we want to increase, so wrong. C, increase the volume of acid. Volume do not affect the rate. Volume is not the 5 factor that can affect the rate. So the best answer is donkey, increase the temperature. Yes, when temperature higher, rate become higher. Yeah, so the question is very straightforward. Okay, so let's move on. Try another few more. Okay, next question, we can look at page 26. Yeah, look at page 26. Okay, so page 26, look at the first question on top. Page 26, the first question. This is SPP trial. Yeah, this is SPP trial, the trial exam paper. Okay, so how are we going to do this? Okay, how are we going to do this question? Same thing, which of the following factor cannot increase the rate? Yeah, A, decrease the size. Size smaller, rate higher. Yes. B, increase temperature. Temperature higher, rate higher. Yes. C, increase the concentration. Concentration increase, rate increase. Correct. D, increase the volume. Volume do not affect the rate. Volume do not affect the rate. Volume is not the 5 factors that can affect the rate of reaction. So D, it's wrong. Yeah. Okay, let's move on. Another one, one more. Turn to page 30. Turn to page 30, 30. Page 30. Which factor does not affect the rate? Same thing, does not. So let's look at it. A, size. Size affect the rate. B, volume do not affect the rate. B. C, concentration affect the rate. D, temperature affect the rate. Only volume do not affect the rate of reaction. Yeah, volume do not affect the rate of reaction. Okay, so that is what we need to know. Okay, lastly, last question before we move on. Turn to page 32. Turn to page 32. Okay, page 32. So for page 32, what we need to do now is this. Yeah, page 32. Okay. So for page 32, look at the first question on top. Okay, the first question on top. All right. The chemical equation show you between the reaction for zinc and sulfuric acid. So we are given an equation. So which of the following factor increase the rate? So we want to increase the rate. We want to make the reaction faster. A, increase the volume. Volume do not affect the rate. No. B, use a low concentration. Concentration lower, reaction becomes slow. The one. C, add a small amount of copper sulfate. When you add an extra substance, you see, we have sulfuric acid and zinc. All in sudden, they add a new filler, copper sulfate. This one has to be catalyst. And you don't need to memorize the copper sulfate as the catalyst. No need. You just need to know, for example, initially the reaction got 2 filler, A and B. All in sudden, they add another one more filler, C. This extra filler that they add in is catalyst. Okay, the extra filler that they added is catalyst. Yeah, So add catalyst can speed up reaction. Yes. If you're not sure the answer is C, look at answer donkey. Use a bigger size of zinc. Bigger size, reaction slower. The best answer is C. Yeah. Lastly, stay on the same page. On the same page, this is SPM 2006. SPM 2006. If you want to cook 100 potato in a short time, so that's a lot of potato you want to cook at a short time, what is the most suitable method? Boil the potato in a pan, boil the potato in pressure cooker, steam the potato in steamer, and fry the potato in a wok. Yeah. So the fastest way for the cooking is pressure cooker. Okay. Pressure cooker can speed up the cooking. Okay, so it can speed up the cooking process. Okay, so that we can settle the whole cooking in a short time. So B. All right. So guys, that's all. Okay, so far for all the questions, are you okay with this? Do you understand all the questions that we discussed so far? Okay, very good. Okay, now let's move on to the next one. Yeah. Okay, now we already understand the 5 factors which can affect the rate of reaction. Okay, now we will learn the most important thing in this chapter. The most important thing in this chapter is called collision theory. Okay, so now we need to know the most important thing in this chapter, collision theory. Okay, so collision theory is the most important subtopic. Okay, it's the most important subtopic. And how important it is. It will always give you many marks. Huh? So collision theory, they can test you and then you can be awarded with 5 to 10 marks. Okay, it can be 5 to 10 marks in your essay question. So if you understand this concept, this is one of the easiest question to score 5 to 10 marks in essay. Yeah, and it is very popular in your paper. Very popular. They ask collision theory almost every single year. Yeah, they ask collision theory almost every year. So please make sure all of you understand what is collision theory. Okay, let me teach you the basic of collision theory first. Okay, so the basic of the collision theory you need to know first. So what is collision theory all about? Collision theory tell you that, okay, for a chemical reaction to occur, if you want a chemical reaction to take place, okay, you must make sure you fulfill 2 requirements. There are 2 requirements. You must get it in order for a reaction to occur. Okay. The first requirement is your reactant. Reactant means raw material. Yeah. Your reactant means raw material. The raw material particle, they must collide. They must collide. Example, if I want A to react with B to form a substance called AB, like this. So I must let the A and B to collide. The A and B must collide, like A and B must langgar. If they never langgar, if they never collide, there is no way they can react. So they need to collide. Yeah, A and B must collide. Then only they can react. Okay, number 2. Okay, so when you come to this collision, you don't think all collision will end up with reaction. Not all collision end up with reaction. So don't think whenever they collide, after collide, they will react directly. No, not necessary. So we have 2 types of collision out there. So let me write underneath here. So we have total 2 types of collision. So we have 2 types of collision. Okay. So the first collision is called effective collision. Okay, effective collision is the collision that end up with reaction. So if you collide and then after collide you got reaction, so that is effective collision. Example, this is substance A and this is substance B, they collide. After they collide, then in the end they combine together, so they react. So that's effective collision. The second one is called ineffective collision. Ineffective collision. Ineffective collision means that they collide and nothing happened. This is a collision that doesn't, okay, ends with reaction. So if you collide, after collide, nothing happened, is called ineffective collision. Example, this is A, move, B, move. They collide. After they collide, the A and B bounce back. The A and B, okay, they bounce back. Nothing happened. So that is called ineffective collision. All right, so guys, up to now, do you understand what is effective and ineffective collision? Can you type in the chat box and let me know, do you understand what is effective and what is ineffective collision so far? Okay, good. All right, so the idea is very simple. If you want a chemical reaction, you need to make sure your raw material must collide. And when they collide, there are two possibilities. If they collide, they stick together, there is a chemical reaction. You call it as effective collision. If they collide, they bounce back, nothing happened, that is called ineffective collision. Yeah, so make sure you understand and able to differentiate these two types of collision. Okay, so we want effective collision only. We don't want ineffective collision. Yeah, so we must know how to get effective collision. To get effective collision, all the raw material, they must collide in a right orientation. They must collide in a right orientation or right arrangement, in a right arrangement, okay? So what do we mean by in a right arrangement? Example, everyone, look at here, all right? So let's say, if I want this particle A and this particle like this to react to become this, okay? So if I want to get this, they must collide in this arrangement. They must collide in this arrangement. This is a correct arrangement. If they collide like this, just imagine everyone, if they collide like this one and collide with this one, okay, like this. So if they move and collide in this way, do you think they can become this? Everyone, do you think they can become this? Type in the chat box to let me know. Can or cannot? Can or cannot? Yeah, okay, cannot. So that's why if you want to make sure that, okay, to get effective collision, the first requirement is that they must collide in a right arrangement. Okay, if the arrangement is correct, then okay. So if the arrangement not correct, then not okay. Yeah. So in this case, the first one here, this is the correct orientation. Okay, this is the correct arrangement. We call it correct orientation. Okay, the second one is a wrong orientation. The arrangement is wrong already. Yeah. So if you want to get an effective collision, first and foremost, you must make sure your raw material can collide in a right arrangement. Number 2, you must make sure that your raw material, your reactant particle must have enough energy. Okay, your raw material, you must have the energy, okay, which is equal. The energy must be equal or higher than a value. This value is called activation energy. Okay. Okay, now we must understand what do we mean by activation energy. So activation energy is this. Okay, so let me write down here. Activation energy is defined as the minimum energy required for a chemical reaction to occur. The minimum energy which you need for chemical reaction to occur. Okay, so I give you an example. Okay, so let's use a non-chemistry example to demonstrate. Then only we come back here. Okay, let's assume activation energy is the passing mark. Just assume activation energy is your passing mark for your chemistry. So what is the passing mark for chemistry? 40 mark. So if you want to pass your chemistry paper, you need to score 40 marks or more. You need to score 40 marks or more. Then only you can pass your chemistry. Example, if you get 39 marks, fail. If you get 20 marks, fail. If you get 47 marks, pass. 54 marks, pass. If you get exactly 40, pass. Yeah. So to pass chemistry, you not necessarily need to score more than 40. Even you are exactly equal to 40 also can. So if you want to pass, you must score more or equal to 40 marks. So far so good? Yeah. So now you use the same concept in chemistry here. So now this 40 mark you change to what? Energy. So if you want a reaction to occur, they must be equal or higher than activation energy. For example, let's say in this reaction, the activation energy, just assume the activation energy is 50 joule for energy. So if these two particles, they collide, they get 49.9 joule. They cannot react because energy not enough. If they get exactly 50, okay, they can react. If they get 74, which is more than 50, yes, they can react. Yeah. So if you want the particle to react, you must make sure that they have enough energy. What do we mean by enough energy? The energy must be equal or more than the activation energy. Yeah. So guys, are you okay with this concept so far? So please remember, if you want a chemical reaction to occur, your raw material must have enough energy. Okay, what do we mean by enough energy? There is always a minimum energy that we needed for the reaction to occur. This minimum energy called activation energy. So if I want the chemical reaction to occur, my raw material, they must have the energy which is equal or more than the activation energy. Okay, so I hope all of you can understand this. Okay, now I will give you 3 questions, see whether you can understand or not. Okay, so the first question, okay, is this. Okay, so I want you all to assume the activation energy just like the passing mark. Just assume the activation energy just like your passing mark. Okay, so let's say if these two particles, they collide in this way, and then they have the energy now. Let's say, just assume everyone, just assume our activation energy is 40 joule, just like the passing mark. So if these two particles, they collide in this way, and then they have 52 joule. They have 52 joule. Type in the chat box. Do you think they can react? Yes or no? Type in the chat box. Do you think they can react? Yes or no? Okay, good. The answer is no. Why? Because although the energy is more than 40, but the arrangement wrong already. They have wrong arrangement. So that's why cannot react. Yeah, you must fulfill two requirements. Then only they can react. Good. What about the second one? So what if now your particle move in this direction, and then the energy they have now is 24 joule. So same thing, everyone, type in the chat box. Can they react? Yes or no? Okay, good. So in this case, the arrangement is correct already, but the energy is not enough because the arrangement, no problem. Now they already collide in the right arrangement, but the energy they have is lower than activation energy. Cannot. Yeah. So what about this? They collide now and then they get, okay, 40.1 joule. So can they react now? Good. The answer is yes. Because now arrangement correct already, energy also no problem. Do remember, to react, the arrangement must be correct and the energy must be equal or higher. So even today you get exactly 40. It's not more than 40. Still okay. Yeah. Not necessary must be more than 40. Even you are equal to 40 is okay. Yeah. So let's do a quick recap again, then we move on. Yeah. So if you want to have a chemical reaction, you must let your raw material collide with each other. So when they collide, they might connect together. That is called effective collision. They might bounce back. That is called ineffective collision. Yeah. So if you want to have effective collision, you must make sure that your raw material must collide in a right arrangement. Yeah, your raw material must collide in a right arrangement. Okay, we call correct orientation, and they must collide with enough energy. So what do we mean by enough energy? The energy must be equal or higher than activation energy. We must have equal or higher than activation energy, then only they can react. Yeah, so that is everything you need to know for collision theory. Okay, so the last thing for this lesson that we need to learn is that, so now we will learn how to, okay, now we will learn how to combine the 5 factors. How to combine the 5 factors affecting the rate of reaction, which we learned early on today, okay, with collision theory. So which means that now we must be able to use the collision theory to explain the 5 factors. So now we need to know how to use collision theory to explain. We must be able to use the collision theory to explain the 5 factor. Because just now we know, for example, temperature increases, rate increases. We know the temperature is higher, the reaction is faster. We know that. But why? Why temperature higher, reaction is faster? Why? We don't know the why. So we have to use collision theory to explain. So that is the most important thing in this chapter. Yeah, this is the most important thing in this chapter. So we will run through the 5 factors. Hopefully, after we run through these 5 factors, you have a better concept what it is. Okay, hopefully after this, you have a better concept what it is and what to expect. Yeah. Okay, let's start. Okay, the first factor is this. Okay, the first factor we need to know is temperature. Okay, factor number 1 is temperature. So we know temperature higher, reaction faster. We know that, yeah. We know that when temperature increases, the rate will increase. We know that. But why? Why when temperature increase, the reaction become faster? Okay, let me use 2 pictures for demonstration. Then only I teach you how to explain. Okay, let me use a simple picture to demonstrate. Then I will show you how to write the answer in your SPM. Yeah. So let's say the first one. Initially, inside here we have zinc and hydrochloric acid. Yeah. So the temperature I use 40 degrees Celsius. Okay, assume the zinc is red color. Okay, let's assume the zinc is red color. The hydrochloric acid is blue color. Yeah. So now, okay, what we do is that now let's try to increase the temperature. So we still use the zinc, we still use hydrochloric acid. The temperature, let's say I doubled it, 80. Yeah. So inside still have the zinc, still have the hydrochloric acid. Now, how are we going to explain using collision theory? How to use collision theory to explain? Let me give you some number. This number no need to memorize. Okay. So let's say, assume that zinc and hydrochloric acid, every 1 minute they can collide for 100 times. So just assume they have 100 collision per minute. No need to memorize. This number only help you to imagine better. So assume every 1 minute we have 100 collision. Okay, out of this 100 collision, there is no way all the 100 collision will be effective, right? There is no way all the 100 collision is effective collision. No way. Some of the collision is ineffective for sure. Let's say we assume out of the collision only 10%. We assume only 10% of all the collision here is effective. Assume 10% is effective. So if we only have 10% of effective collision, okay, let's assume that if let's say we have only 10% is effective, then we get 10 effective collision per minute. Okay, so we only get 10 effective collision per minute. Yeah. All right. Now, when we increase the temperature, what happened? So I want all of you to understand a very important thing. So let me write tips on the left-hand side here. So I want all of you to understand that temperature, it's always related with kinetic energy. Temperature always related with something called kinetic energy. So when temperature increase, kinetic energy will increase. Yeah, temperature always related with kinetic energy. So when the temperature increases, kinetic energy will increases. Okay, so now initially when we use a low temperature 40, all the particle here they have low kinetic energy, so they don't have so many energy. But when temperature increases, all the particle here has high kinetic energy. So all the particle now got high kinetic energy. They are more energetic now. They are more energetic. They have more and more energy. Yeah. So when they have more energy, what will happen? Okay. So remember, guys, the particle they are colliding. So if they have high energy, what will happen is this, okay? So let me move this one first. Okay, so when the particle has high energy, they will collide more and more frequently. They collide more and more, yeah? Because when the temperature higher, all the particle, they can move faster like this. Initially, low temperature, it move slow, move slow, move slow, move slow. But at high temperature, the particle can move very fast like this. Yeah, they can move very fast. Yeah, so low temperature move slow, high temperature move fast. The faster they move, the more they collide. The faster they move, the more they can collide. So now you are not getting 100 collision now. Now maybe you will get 500 collisions per minute. Okay, now we can get as much as 500 collision, okay, per minute. Okay, so when they collide more and more now, okay, same thing, we assume only 10% is effective collision. So out of 500, 10% is 50. So now we have 50 effective collisions per minute. Okay, now we have 50 effective collision per minute. So you can see now, just now, we have total, okay, just now we have total 100 collision per 1 minute. Now, when the temperature increases, all the particles got more and more energy. When they have more and more energy, they can collide more and more often. When they collide more and more often, therefore, we will get many effective collision. We will get many effective collision. So that is what we need to know. All right. So guys, are you okay with this concept? Just type in the chat box and let me know. All right, good. Now, how are we going to write this? If in exam, if they give us a sample question, they ask us how temperature, okay, increase the rate of reaction. How temperature increase the rate of reaction. Okay, so if this question came out in exam and then they give us 4 marks, how are we going to answer it? Yeah, so first of all, you can write something like this. Okay, so when temperature increases, when we increase in temperature, our raw material is called reactant particles. Okay, our reactant particles, our raw materials, they will have higher kinetic energy. Yeah, temperature always related to kinetic energy. When temperature increases, all the particles got more and more energy. When the particle got more and more energy, so your raw material, the reactant particles, now it will actually move faster, yeah, because the more energy they have, the faster they can move. So since they can move faster, they will collide more and more frequently, right? Okay, imagine this particle and this particle. This one move very slow. This one move very slow. Very unlikely they will collide. But if now temperature higher, these two particles has a lot of energy, it move very fast. It move very fast. The faster they move, the more they can collide. Yeah, so learn these magic words. Okay, so we will use a word called frequency. Okay, frequency. Frequency means how often. How often. Okay, in BM they call kekerapan. Okay, frequency of collision increases. Okay, they will collide more and more frequently. Okay, now one more thing to highlight here. In SPM, you must mention who is colliding. Okay, so this is tips number 2. Okay, so in SPM, you must mention, okay, you must mention or you must tell, okay, you must mention which particle, okay, you must mention which particles they are colliding. You must tell people who is colliding, okay, who is colliding in SPM, yeah. So how to know who is colliding? Now this is very technical. I need you to pay attention. This is very, very technical. I need you to pay attention. Okay, now look back your chemical, look back to your reaction. So our reaction, what we have zinc and hydrochloric acid. We have zinc and hydrochloric acid. So how to write zinc and hydrochloric acid? You cannot write frequency of collision, okay, between frequency of collision between zinc and hydrochloric acid. They won't give you the mark. They won't give you the mark. So what you should do is this, okay? So you have to be careful here, okay? So zinc is Zn. So when zinc only come alone, it does not combine with anything else. If zinc come alone, it does not combine with anything else. You have to call it as zinc atom. Okay, anything come alone, not combined with anything else, is called atom. Example, magnesium come alone. Magnesium do not combine with anything. Magnesium atom. Al, aluminium. Okay, aluminium. Right, aluminium. Also same thing. All right. Aluminium come alone, it's atom. All right. So make sure you all put the word atoms. Yeah. Make sure you put the word atom. Anything who come alone, they are atom. So you must write the word atom. If you only write zinc without atom, they can penalize you. Okay, another one is the hydrochloric acid. Okay, for hydrochloric acid, this is something we learned in the previous chapter. This is something we learned in previous chapter. Yeah. So you must understand that, okay? So this is an important concept. Okay, we learn this concept in the chapter of acid. Yeah, all acids, they have a very important thing called H plus ion. All the acid, they have H plus ion. Example, hydrochloric acid, you have H plus. Sulfuric acid, you have H plus. Nitric acid, you have H plus. So all acid, the most important thing is H plus. The most important thing in acid is H plus. So here we have hydrochloric acid. You don't need to write the hydrochloric acid. You just need to write H plus ion. So in this question, no matter what acid they give you, even today they give you sulfuric acid, you also write H plus. Even today they give you nitric acid, you also write H plus. So all acid, you just need to write H plus. All the acid, you just need to write H plus. That is good enough already. Yeah. So frequency of collision between zinc atom and hydrogen ion increases. So you need to specify who is colliding, zinc and H plus ion. Zinc and H plus ion. All right. So make sure you mention that. Yeah. You must clearly mention who is colliding. Yeah. You must clearly mention who is colliding. Guys, so far so good. Anyone got stuck or don't understand why I put zinc atom and why I put H plus ion? Anyone don't understand? Okay, good. All right. So if today we have magnesium and sulfuric acid, then what is the particle that is colliding? So if we have magnesium and sulfuric acid, magnesium come alone, you call magnesium atom. Sulfuric acid or acid H plus ion. So magnesium atom will collide with H plus ion. So that is what you need to know. Yeah. So if you understand this concept, then it shouldn't be too hard, lah. Okay. So that's what you need to know. All right. So when frequency of collision increases, therefore frequency of effective collision will increase as well. Okay, frequency of effective collision increases. Yeah, so that is what we need to know. Okay, many people ask, sir, how come frequency of effective collision, we don't need to mention who is colliding? Because just now you already tell who is colliding, so now even you don't tell is okay. Okay, just now you already mentioned who is colliding, so for now, even you don't tell who is colliding is okay. But some people ask, sir, if here I write one more time, frequency of collision between zinc and frequency of effective collision between zinc atom and hydrogen ion increases, can or cannot? Can. You just need to tell the examiner minimum one time. You just tell them one time who is colliding. If you want to mention more than one time, it's okay. Minimum one time. Okay, minimum you must mention who is colliding for one time. That is good enough. Okay, so this question, how they give you 4 marks. Okay, the first mark is awarded when you write when temperature increases, the reactant particle has higher kinetic energy. Okay, 1 more mark is awarded if you write reactant particle move faster. 1 mark is awarded when you mention frequency of collision between zinc atom and H plus ion increases. And 1 more mark is awarded if you write frequency of effective collision increases. So this is how you get yourself 4 marks. This is how you secure 4 marks for yourself. Okay, so it's not very hard. Most importantly is you understand the question. If you understand the question, you know how it works, it shouldn't be too hard for you. Okay, so guys, that's all for temperature. Okay, so I hope everyone understand how to use collision theory to explain about temperature. Yeah, that is factor number 1. Okay, so now let's move on to factor number 2. Factor number 2 that we need to learn, it's called concentration. Okay, factor number 2, it's called concentration. So concentration is another factor that can affect the rate of reaction. Okay, concentration is another factor that can affect the rate of reaction. So the concept is when concentration increases, okay, the rate of reaction increases. Yeah, concentration increase, reaction become faster. Why? So same thing, let us learn why. Why when the concentration increases, the rate of reaction increase as well. Okay, so let me give you some idea here. Let's say for the first beaker we have, okay, magnesium. Okay, we use magnesium and we react with, okay, 50 cm cube, okay, 1 mole per dm cube hydrochloric acid. Another one here, we have magnesium react with 50 cm cube, 2 mole per dm cube hydrochloric acid. Yeah. Okay, so let's draw a diagram. So this is magnesium, and then this is magnesium. Okay, now what is the difference here? Here we use 1 mole per dm cube hydrochloric acid, and this one we use 2 mole per dm cube. Okay, we learned back in previous chapter of acid, whenever you see anything ended with mole per dm cube, this is concentration. Anything ended with mole per dm cube called concentration, or another word they can use, molarity. Yeah, when you see anything ended with mole per dm cube, that is called concentration or we call molarity. So you can see when they use 1 mole per dm cube, that is a low concentration. But when they use a 2 mole per dm cube, that is high concentration. So when we use high concentration, what is the problem? What is the deal? When we use high concentration means we have more particle. Example, just assume 1 mole per dm cube got 4 particles. Green color, this green color is the hydrochloric acid. Now, if you increase the concentration, you double up the concentration. So when you double up the concentration, you double up the hydrochloric acid. So now we have to drop 8. Yeah, so we have 8 hydrochloric acid now. Because when we double the concentration, we have more and more hydrochloric acid particle. We have more and more hydrochloric acid particle. Okay, guys, type in the chat box and let me know. Are you okay with this concept? Are you okay with this concept? Okay, good. So when concentration increases means that you have more and more particles. Okay, when concentration increases means that you have more and more particles. Okay, so let's look at the number again. All right. So now, initially, okay, here you have less particle and here you have more particle. So what happened? Okay, so let's use an example sample question to demonstrate how concentration affect the rate of reaction. Okay, how concentration increase the rate of reaction. Okay, if this is the question, how are we going to answer? How concentration increase the rate of reaction? Okay, so let's say this question gives us 3 marks. So how are we going to write it? How are we going to write? Yeah. So first one, okay, the first mark, okay, watch out the keywords. Those things I highlight is the important keyword. Yeah. Okay, so first of all, you must know, in this case, which concentration they play around. They change the concentration of hydrochloric acid. So you must mention when concentration of hydrochloric acid. So you need to specify this concentration refer to who? Hydrochloric acid. When concentration of hydrochloric acid increases, so we have more and more, okay, what? Okay, acid must have what particle? Everyone, we learned before, type in the chat box, let me know, what is the most important particle for acid? When it comes to acid, what is the most important particle? No matter what acid it is, hydrochloric acid, sulfuric, nitric, whatever acid, all acid must have one important particle. What is a particle, everyone? Okay, good. I can see you type in the answer already. Okay, the particle, all right. The particle is H plus. You can call it as H plus or you must write hydrogen ion. You must put the word ion. If you don't put the word ion, it's wrong. Because if you only write hydrogen, examiner might thought you refer to H2. No, you must mention hydrogen ion, or you can write H plus ion. Anything got charge, you must put the word ion. Yeah. So yes, the most important thing is H plus ion. When concentration of acid increases, you have many H plus ion. All the green color here is actually H plus ion. All the green color is H plus ion. So when you increase the concentration, you get many green color, which means that you have many H plus ion. So you have, this is the magic word, you have more H plus ions per unit volume. Okay, what it means by more H plus ion per unit volume means that in the same volume, 50 and 50, in the same volume, because they didn't change the volume, what? They didn't change the volume. So in the same volume, we have more and more H plus. That is called more H plus ion per unit volume. Yeah, we have more and more H plus ion per unit volume. Okay, so when we have more and more H plus per unit volume, so when we have many particles like this, so it is very crowded. It's very crowded. When it's very crowded, it's very easy to collide. Imagine this, we have two classrooms. These two classrooms same size. First classroom got 3 students, which they move around. Second classroom, okay, same size of classroom. Now you put 10 students in the classroom. So when you put 10 students in a classroom, it becomes very crowded. When it's very crowded, they should able to collide more easily. So here they should collide very easily, okay, compared to this one. So when we have more and more H plus ion per unit volume, so the whole thing become more and more crowded. When it's getting more and more crowded, okay, okay, so when it's getting more and more crowded, so what we need to know on the next thing, yeah? So when it's getting more crowded, so you will have more and more collision, okay? You will have more and more collision, okay? So frequency of collision will increases. Frequency of collision increases, okay? And you must mention who is colliding, okay? You need to mention who is colliding, yeah? So who is colliding here? So now we have magnesium and hydrochloric acid. Magnesium and hydrochloric acid. Magnesium come alone, so we have to write magnesium atom. And then all hydrochloric acid, all the acid you must have H plus. All acid you will write H plus. Frequency of collision between magnesium atom and H plus ion will increases. So remember, you must specify who is colliding. In SPM, you need to mention who is colliding. So when they collide more and more often, when there are more and more collision, therefore, when there are more and more collision, frequency of effective collision will increases. Frequency of effective collision will increases. So when you get many effective collision, your reaction can be faster. Yeah. So in this case, where the 3 mark coming from? The first mark you get when you write concentration increases, you have more and more H plus ion per unit volume. Second mark is awarded when you mention when you have many H plus, you have more and more collision between magnesium and H plus ion. You must mention who is colliding, okay? You must mention who is colliding, okay? Then the next one, okay? The next one, it's you must mention frequency of effective collision increases, yeah? Frequency of effective collision increases. So this is what you need to know, okay? When you understand the whole concept, so it's very easy when you come to the explanation, okay? So that is what you need to know, all right? So I hope all of you can understand, yeah? All of you can understand the idea and the concept here, okay? Okay, so that's the second one, okay? All right, so any questions so far up to now? Okay, all right. So that's the second one. So now we will go on with the next one, with the third factor. Okay, the third factor is called pressure. So pressure is very, very rare. So far in SPM, never been asked. Okay, pressure is very, very rare. So far, SPM never asked even once. The only time they ask is the pressure cooker. Yeah, so far when it comes to pressure, the only thing they ask is pressure cooker. That's it. Yeah. So now, so this is less important. Okay, this is less important. So for pressure, what you need to know is this, okay? We need to know when pressure increases, the rate will increase as well. When pressure increase, the rate increase, okay? So what is the logic? What is the logic and how it works, okay? So pressure, you must relate with one important thing from physics, okay? So you need to recall back a concept that you learned in physics. In physics, you will learn a concept called Boyle's law. You will learn Boyle's law in physics. Boyle's law tells us that pressure is inversely proportional with volume. Pressure is inversely proportional with volume, which means when the pressure increases, volume will decrease. When the pressure decreases, volume will increase. This is called inversely proportional. Okay, this is called inversely proportional. Yeah, even you never learned about Boyle's law, you didn't take physics, also okay. You just need to know that pressure always related with volume. Okay, and the relationship is opposite. Okay, the relationship is opposite. Yeah, so that is what we need to know. All right, now, okay, I give you a simple diagram here. So hopefully from this diagram, you can imagine better, okay? So let's say we have a reaction like this, okay? So here we use a high pressure, okay? So we compress it, and pressure only works for gas. So let's say I use a low pressure. So this one is a low pressure, and inside here we have some particle. Okay, we have some particle here. Okay, and inside here we have some particles. Okay, so now when I use a high pressure, I compress it. You see, now I press it hard, press it. So I compress it to increase the pressure. This is high pressure. Okay, so you all should be able to see. Okay, when you use a low pressure, the volume is big. You have a big volume. When you use a high pressure, the volume is small. That's why I say pressure and volume is inversely proportional. Okay, inside here, the particles still the same. Use the high pressure, you won't get more black particles, still 3. Use a high pressure, you won't get more red particles, still 3. Yeah. So you still have same amount of the black and the red color particles. Okay, so now what happened? So when we increase the pressure, as you can see, okay, let me show you how they ask the questions. Let's say the question, how pressure increase the rate? How pressure increase the rate of reaction? How the pressure can make the rate of reaction higher? Yeah. So same thing, if this question give you 3 marks, so how are we going to explain? Okay, so when we increase the pressure, as you can see, the volume getting smaller. Okay, so when pressure increases, okay, when pressure increases, the volume becomes smaller or volume decreases. Okay, when pressure increase, volume decrease. When the volume decrease, what you can see from this picture, here have 6 particles, here also have 6 particles. But the difference is what? When volume decreases, all the 6 particles, they are very close to each other now. Okay, now all the 6 particles, they are very, very close to each other. Okay, so what you're going, okay, when the pressure increase, volume will decrease. Okay, so what happened is that you can see that now the gas particle they are getting closer. All the gas particles, they are getting closer to each other. All the gas particles, they are getting closer to each other. Because when we compress them, we squeeze them together. When we compress them, we squeeze them together. Yeah, we squeeze them together. So that is what we need to know. Yeah. All right. Now, when the gas particle getting very close to each another, so when they get very close together, they were able to collide more and more frequently. Okay, frequency of collision. Okay, so you must mention who is colliding. So for this question, did I tell you what is the black particle? Do I tell you what is the red particle? For this question, no, I didn't tell. If I tell you the black particle is zinc, then at least you can put the word zinc atom. Okay, but no, I didn't tell. So if the question didn't tell, if the question didn't tell you who are the substance, you can use the word frequency of collision between reactant particles. You can put the word reactant particle if you don't know what it is. Yeah, frequency of collision between reactant particle increase. Okay, so when the particle they collide more and more often, why they collide more and more often? Because they are very close to each other. Yeah, when the particle very close to each other, it's very easy for them to collide. Just imagine this. Initially, you have a big room. You put, okay, 10 students. Now, you cut the room size become half. You still have 10 students. When 10 students squeeze in a smaller room, they are very close to each other. So it's more easily for these 10 students to collide. So that is what you need to know. Yeah. So frequency of collision increases. When frequency of collision between the reactant particle increases, therefore, the frequency of the frequency of the effective collision also increases. So the effective collision, okay, also increases. Okay, so when we get many effective collision, your chemical reaction getting faster. That's what you need to do. Okay, so where the 3 mark coming from? The first mark is awarded when you mention pressure increases, the gas particle get closer to one another. Second mark is awarded when you mention the particle collide more and more frequently. The third mark is awarded when you mention your frequency of effective collision also increase as well. So this is how you get your 3 marks in this question. Yeah. So do it in a very systematic manner. You can see all the question we keep talking about what? Collision theory only. We keep talking about collision theory. The most important thing in this chapter. Yeah. Okay, now let's go for factor number 4. Yeah, let's finish it. So factor 4 and factor 5. Factor number 4. Factor number 4 is size of particle. Factor number 4 is related to size of particle. Okay, like what they say, size of particle only work for solid only. Yeah, so size only for solid. Okay, so powder is a small size. If they use powder, so the size is small. Okay. If they use chip or they use granule, so the size is big. Yeah. So we know the concept that, okay, the concept that we know is the smaller the size, the higher the rate. The smaller the size, the higher the rate. So how are we going to explain? Okay, so let's look at here. All right. So let's say I give you a picture again. So let's have a picture here. Okay. So when we have a smaller size, okay, how does it impact? Okay, let's say the first one here, we put a hydrochloric acid. So let's say for both, we put hydrochloric acid and then we add with this substance, hydrochloric acid, we add with, okay, over here, we have calcium carbonate powder, or they can call it limestone, calcium carbonate, sometimes they also can call it as limestone, or sometimes they also can call it as marble. They can call calcium carbonate as marble, or they can call it as limestone. Yeah? All right. Hydrochloric acid plus calcium carbonate, this is granule, means a bigger piece. Then another one, we have calcium carbonate powder. So one use granule, which is the bigger size. One use powder, which is a smaller size. Okay. So now let me give you a sample question. Let's say the question asks, how the size of particle, how the size of particle affect or increase, how the size of particle increase the rate of reaction. Okay, let's say this is the question. All right, so this question, let's say they give you 4 marks. So how are we going to tackle the question? Okay, first of all, you must mention who has a smaller size. Okay, so the first mark you can write calcium carbonate calcium carbonate powder has smaller size of particles. Calcium carbonate powder has a smaller size of particles. They have a smaller size. Powder is smaller than granule. Okay, then since it's smaller, so what? Okay, size always related with this. So this is another tips. Okay, so talking about size, size always related to a very important concept called total surface area. Size always relate with total surface area. So the idea is that the smaller the size, the larger the total surface area. The smaller the size, the larger the total surface area. Okay, what do we mean by this? Example, initially, if you have a big size of steak, you want to cook it. So all this blue color is the area. Okay, all the red color here is the area that exposed to heat. Now, if you cut the steak to become smaller, if the steak now, you cut it to become smaller like this, okay? If you cut the steak to become smaller like this. All right. So if the stick is become smaller, so you can see the surface area now is getting more and more. How come the surface area is getting more and more now? Because many people thought the size smaller, the area should be smaller. Example like this. Initially, okay, what is the surface area? The red color part only. When this thing cut into half, when you cut it into half, what is the surface area? Still the red color part, but add on with the blue color one. Add on with the blue color one. So this blue color initially is hidden inside. So when you don't cut it, this blue color is not a surface. It's not a surface. So the blue color is not counted as the area. But if you cut it becomes smaller, when you cut it becomes smaller now, so when you cut it becomes smaller, okay, when you cut it becomes smaller, so you have more and more area exposed, okay, to outside. Okay, so everyone, can you type in the chat box? Can you understand this? The smaller the size, the bigger the surface area. Are you okay with this? Okay, so guys, can you type in the chat box and let me know? Are you okay with the concept? The smaller the size, the bigger the surface area. Okay, good. So when the size is smaller, so you have greater total surface area. You have greater total surface area. When you have bigger surface area, so what? You have greater area exposed for collision. You have more and more area that can collide. Yeah. Example like this. Just now you only can collide here. Now when you cut to smaller size, you can collide in many different ways. Yeah. You have more and more area that can collide now. So you will definitely have more and more collision. Yeah. So you have definitely more and more collision. So you write the word frequency. Yeah. So frequency of collision. Okay, same thing. You must mention who is colliding. You must mention who is colliding. So now who is colliding for this case? So in this case, our raw material is hydrochloric acid. All acid must have H plus ion. All acid must have H plus ion. Another one raw material is calcium carbonate. So calcium carbonate is CaCO3. CaCO3 is not alone because you have Ca, you have C, you have O, it's not alone. So you cannot call it as atom. CaCO3, you don't see any charge on top. You don't see any charge on top. You cannot call it as ion. So for CaCO3, you don't need to put the word atom or ion. You just need to copy back CaCO3. Frequency of collision between H plus ion and CaCO3 increases. Okay, when you have more and more collision, okay, when you have more and more collision, frequency of effective collision, okay, frequency of effective collision also increases. Okay, so it's not very hard. You just need to mention when we use a powder, powder has a smaller size. So when powder has a smaller size, it has a greater surface area for collision. When you have a bigger area to collide, when you have a bigger area to collide, the frequency of collision will increase. Yeah, frequency will increase. Okay, so when they collide, then when they collide more and more often, you will get more and more effective collision. Okay, that is what you need to know. All right. So that is for size. Yeah, size. The smaller the size, the greater the total surface area. The greater the total surface area, the more and more area they can collide. The more area they can collide, yeah, the more and more area they can collide, you have many collision. The more collision you have, the more often they will react. So frequency of effective collision increases. Okay, so guys, I hope all is good. So let's spend the last 5 minutes. Let's spend the last 5 minutes to learn the last factor. Okay, the last factor. So let's learn the last factor. The last factor is catalyst. Yeah, so this is factor number 5. Okay, so we extend a bit. Yeah, give me 5 more minutes. Let's finish it. Factor number 5. So the factor number 5 is actually called catalyst. Okay, so catalyst. Okay, what's the concept again? When we use catalyst, the rate of reaction become higher. Yeah, the chemical reaction become faster whenever we use catalyst. Yeah. So there is a few things you need to know for catalyst. Okay, there is a few things that you need to know for catalyst. Yeah. So catalyst, what we need to know. Okay, what we need to know when you come to catalyst. First of all, okay, before we start to do this collision theory, okay. So catalyst, okay, is a special substance that can speed up the reaction. Okay, catalyst is a special substance will speed up the reaction. But catalysts do not increase or do not decrease. Okay, catalysts do not increase or decrease the amount of product. Okay, catalysts, okay, they do not increase or decrease the amount of product, which means that before you add in catalyst, you produce 1 kilogram of product. After you add catalyst, you still get 1 kilogram of product. It's the only difference is the reaction become faster. Okay, the reaction is faster, but it won't increase or decrease the amount of product. Product. Next one, you must know catalyst is highly specific. Catalyst is very specific. Okay, catalyst is very specific. Okay, what we mean by specific? Specific means that, okay, certain catalysts only can speed up certain reaction. Okay, so certain catalysts only can speed up certain reaction. Example, if I have a catalyst called A, the A can speed up the reaction called W. Okay, now you cannot take the catalyst A to speed up. Okay, now you cannot take the catalyst A to speed up reaction C, cannot. Okay, catalyst A can only speed up reaction W. That's it. You cannot use catalyst A to speed up other reaction. It's highly specific. That's what you need to know for catalyst. And lastly, catalysts do not use up. Okay, what it means by do not use up? Do not use up means that the catalyst, the amount will not change one. Initially, let's say when the reaction started, you have 1 kilogram of catalyst. When the reaction started, you have 1 kilogram of catalyst. Once the reaction finish already, you still have 1 kilogram of catalyst. Catalysts do not increase or decrease. Okay, the amount of catalyst will not change one. Okay, catalyst is only speed up the reaction. The amount of the catalyst do not change one. Okay, if you start with 10 kilogram of catalyst, after the reaction, you will still have 10 kilogram of catalyst. That's it. Okay, so I want you to know catalyst speed up the reaction in a very special way. Okay, catalyst able to speed up the reaction in a very special way. Okay, catalyst, the way they speed up the reaction is very different from temperature, concentration, pressure, and size. It's very special. So how catalyst speed up the reaction? Okay, so same thing, let me draw two pictures. Okay, the first picture is this. We have zinc plus hydrochloric acid. Second one, we have zinc plus hydrochloric acid plus copper sulfate, which is the catalyst. So on the left-hand side, we don't have catalyst. On the right-hand side, we have catalyst. So let's say the zinc is the blue color particle, and then the hydrochloric acid is the red color particle. Just assume. Okay, that's what we have. Okay, so let's look at the number again. Okay, catalyst is very special. Look at here. So initially, let's say we have 100 collision per minute. We have 100 collision per minute. Okay, we have 100 collision per minute. Let's say we assume only 10% it's effective. Only 10% is effective. So out of the 100, 10% is effective. So we only have 10 effective collisions per minute. Okay, this is something we learned just now. Okay, after you add catalyst, the number of collisions still the same. You still have 100 collision. You don't get more and more collision, unlike temperature. When you increase temperature, when you increase pressure, when you increase the concentration, when you use a smaller size, they will collide more and more times. But catalyst, no. When you add catalyst, you still collide for 100 times only. They didn't collide more and more. But what catalysts do? What catalysts do? Okay, so let's say the question is how catalysts speed up your chemical reaction. How the catalyst speed up your chemical reaction. Okay, catalysts do a very special way. Okay, so catalyst can do this thing. It can help you to lower the activation energy. Catalyst can lower the activation energy. Okay, everyone, we learned early on today what is activation energy. Activation energy is the minimum energy that we need for the reaction to occur. So let's say just now the passing mark is 40 mark. So 40 mark, okay, or let's say the mark to get A is 70 mark. So not many people can get A. But after we add catalyst, instead of 70 mark to get A, now we just need to score 60 mark. We can get A already. So when now the mark to get A is 60 mark, definitely more and more people can get A, isn't it? Just now maybe you are 65 marks. If they put 70, so you are not an A. But now if they lower down the standard, they make it 60 mark to get A. So now if you have 65 mark, you are A already. So when they lower down the activation energy, more and more particle can achieve that. So more and more reactant particle. Reactant particle means raw material. More and more reactant particles. More and more raw material. Okay, they can achieve. More and more raw material can achieve the lower activation energy. Okay, let's say just now, if the activation energy they put 70 joule, not many people, not many particles got 70 joule. But now if they lower down the activation energy from 70 joule to 60 joule, more and more particles got 60 joule. Yeah. So when more particle can achieve the lower activation energy, means what? The percentage of effective collision is higher. So maybe now we have 20% is effective. Yeah. 20% is effective, for example. Yeah, all these numbers don't memorize, just for demonstration. All these numbers no need to memorize. So when we add catalyst, we lower down the activation energy. When activation energy is lower, more and more particle can achieve that. When more particle can achieve that, let's say now 20% out of 100, we have 20 effective collision now. Now we have 20 effective collisions per minute. So you see, just now 1 minute got 10 reaction, now we got 20. The reaction still faster, although the number of collision never change. Okay, just now collect 100 times, now still collect 100 times. But how come the reaction become faster? It's because frequency of effective collision increases. So you must mention who is colliding. So who is colliding now? We have zinc. Zinc come alone, zinc atom. Hydrochloric acid, acid is H+. So zinc atom and H+ ion. So frequency of zinc atom on H+ ion increases. So when we get many effective collision, our reaction become faster. So I want all of you to notice, okay? I want all of you to aware that catalyst also can speed up the reaction, okay? Catalyst can speed up the reaction, but catalyst, the way they speed up is very different, okay? So you see all the other factors, they always increase the collision, they increase effective collision. All the other factors, they always increase collision, effective collision. But if you look at catalyst, before and you add catalyst, you still have 100 collision. So you do not increase the number of collision. You only increase the effective collision directly. So guys, are you okay with this concept? Would it be very confusing? And this question can give us about 3 marks. So 1 mark is catalyst lower the activation energy. 2nd mark, more particle can achieve that. And then the 3rd mark is frequency of effective collision increase. Okay guys, good. Okay, with that being said, we are all done with the most important thing of this chapter, which is 5 factors affecting rate of reaction and also the collision theory. This is most important part in this chapter. It can bring you a lot of marks. Yeah. So in next lesson, we will discuss some exercises, some past year question, so you have a better idea how the question for collision theory can be tested in the exam. Okay. All right. So guys, I think that's all. Okay, I think that's all for today. Yeah. So all right, I hope you all learned something. It's not very hard. Most importantly is understand the concept.